So this is the continuation of the test on variance and the statistical deviation of a normal distribution. So I will be discussing the sample number 2 and the sample number 3. So let me read it for you. So Jollibee claims that the variance in customer service times, it was stated that from order placement to delivery across all its location is 15 minutes squared. So a district manager believes that the consistency has changed and suspects the true variance is simply different from 15. The manager collects the data from a random sample of 28 service times from various branches. The resulting sample variance S squared is calculated to be 24.5 minutes squared. So test the district manager's suspicion at the significance level of our alpha level is 0.02. So assume that the service times are normally distributed and the observations are different. So going back, so I have listed here our given values from the problem. So we have here our null hypothesis, which is it was stated in the problem that the time across all its location is 15 minutes. So this is our null hypothesis. So for our alternative hypothesis, so it was stated na sabi sa problem na si district manager daw, he believes that the consistency has changed and suspects the true variance is simply different from 15. So it means na hindi siya equal to 15. So we can conclude that this is a two-tailed test. So next, in-identify naman natin ang other givens, which is the sample n 28 and the sample variance, which is the 24.5. Next, it was stated in the problem as well na ang significance level of the alpha is 0.02. So after we list down this given, we have to determine first the degree of freedom. So the formula of degree of freedom, ito ay na-discuss din ni BJ, which is the n minus 1. So we have our n here, which is 28. So 28 minus 1 is basically equal to 27. So our degree of freedom is equal to 27. Next, after we got our degree of freedom, we will now use the formula of the test statistic that we will use, which is the chi-squared. So what is the formula? So it was discussed by BJ as well, na it is n minus 1 multiplied to the sample variance squared. So multiply to s squared over the population variance, which is ayan, sigma squared. So before we proceed on computing the chi-squared, let us first draw the graph of this problem. So since we have a two-tailed test, let me draw it. Let me make it clear. Yan. So since this is a two-tailed test, so going back, we have here our rejection region, which is this is 0.05 stated in the problem. This is 0.05 as well. And we have here our acceptance region, na 0.95. Since to get the accepted region, we just have to subtract 0.05 to 1. So that is 0.95. So i-move ko lang this one since we will solve later on. Ayan. Since we need to get the critical values of this one. We need to get the critical value here as well. So we will use the formula of the chi-squared. So how do we get that? So let's just substitute. So let me move this table here. This graph. So let us now substitute from our given. So n minus 1. So this is 28 minus 1 multiply to 24.5 over we have our our population variance, which is 15. So to calculate the value, we will get 44.1. Now that we get the value in the formula of the chi-squared, we can now determine the critical value. So I noticed something na mali ko, so my apologies. So this is 0.02. We have here 0.02. Since we have a two-tailed test, so this is a over 2, so alpha over 2. So the value of that is equal to 0.01. Ayan, so this is 0.01 as well. Let me change the color so that hindi kayo malito. We make it red, this one as well. Wait, wrong color. Ayan. So this one, this shaded region, we can now get this one later on. So this is, since this is 0.01, we can determine that this is 0.08, 0.98 rather. So going back to our problem, so we have here so this is wrong. So we have here the upper tail and the lower tail. So to get the upper tail, we will use 0.01. For the lower tail. So for the upper tail naman, we will use 0.99. So this is 1 minus the alpha level over 2, which is 0.99. So by using the degrees of freedom and the by using the degrees of freedom and the significant values and the alpha values, we can now use the chi table here. So we will now locate the 0.99 and 0.01 in 27. So we have 27, the degree of freedom here. So in 0.99 we have 12.879, and in 0.01 we have 46.963. So 12.879. So this is, let me move this one. So in the left tail we have a critical value of 12.879. And So this is 12.879. And for our right tail, we have 46.963. So here we have 46.963. So now that we have our critical values, now that we have these values, so we will locate the 44.1. So 44.1 is somewhere between the 12.879 and the 46.963. So let's just say we have here our 44.1. What we can conclude here is that since the 44.1 is in between 12.879, so this is the left critical value, and 46.963, which is the right critical value, so we can conclude that it was in the non-rejection region, so leading us to fail to reject the null hypothesis. So to conclude, since we reject the null hypothesis, since we fail to reject the null hypothesis, so we will accept that the service times across all its location is proven to be 15 minutes. So that is our conclusion in this problem. So let us proceed to our second problem. So for our third problem rather, a large coffee shop chain used a high volume espresso machine. The maintenance team asserts that the standard deviation of the espresso shot volume is at most 3 milliliters or ml. If the standard deviation is higher, it indicates inconsistency and wasted product. A quality assurance auditor suspects that the machine is now less reliable, meaning the standard deviation is greater than 3 ml. The auditor takes a random sample of N, which is equal to 19 shots, and measures the volume. The sample standard deviation, or the S, is found to be at 3.9 ml. At a significance level of which is the alpha level, is equal to 0.1010, is there enough evidence to conclude that the population standard deviation is greater than 3 ml? So assume that the shot of volumes are normally distributed. So in this problem, so I have prepared here the problem. So first, we have to determine the null and alternative hypothesis first. So here, our null hypothesis and alternative hypothesis. So based on our given problem, it was stated that the maintenance team asserts that the standard deviation of the espresso shot volume is at most 3 milliliters. So it means the standard deviation is less than or equal to 3 ml. So that is our null hypothesis. So it was stated also, so for our alternative hypothesis, if the standard deviation is higher, it indicates inconsistency and wasted product. A quality assurance auditor suspects that the machine is now less reliable, meaning the standard deviation is greater than 3 ml. So for our alternative hypothesis, it was stated that the standard deviation is greater than 3 ml. So after we determine the null and alternative hypothesis, we will we will now determine our sample, which is n. So it was stated in the problem that n is equal to 19. Next is the standard deviation. The sample standard deviation, so S, is equal to 3.9 ml. Next, so we also have significance level, the alpha level of 0.10 So it was asked in the problem that is there enough evidence to conclude that the population standard deviation is greater than 3 ml. So assume that the shots are normally distributed. So after we listed our given, we will now get the degree of freedom. So this is the same as the previous problem, so step by step. So next we will now determine the degree of freedom with the formula of n minus 1. So our degree of freedom, so which is 19 minus 1, which is equal to 18. So our degree of freedom is 18. Next, after we determine the degree of freedom, we will now calculate the test statistic using the chi-squared rather. So let's put here the formula for the chi-squared. So let me just copy this one since we used this a while ago. So as explained, this is the formula of the chi-squared, which is n minus 1 the quantity of n minus 1 multiplied to the squared of the sample standard deviation over the population variance squared. Next, so let me substitute the given formulas. So we have n minus 1, which is 19 minus 1 multiplied to the value of our S, 3.9. So we have 3.9 here. So we will square this one. Next, we have the value of the variance. So it was stated in the problem that the variance is greater than or equal to 3 ml. So let's put 3 here. So this is 3 squared. So after solving this in your calculator, ang lalabas ay 30.42. So we will use this later to determine if we fail to reject the null hypothesis or we reject the null hypothesis. So since we have here greater than, so based on our alternative hypothesis, this will be a right-tailed test. So let's draw the graph of a right-tailed test for a while. Ayan. So for a right-tailed test, so this is our shaded region. So this is the rejection region. And this space here is the acceptance region. So it was given in the problem that our significance level is at 10%. So this is 10%. So or 0.10 rather. So this is 0.10. So this is the rejection region. And this one is the accepted region. So it means that our accepted region is at 0.9. Next, since we have here our uh, alpha level, we will use this to determine the critical value. So, since we have here our degree of freedom na 18, so going back to our table, let me just scroll this down and erase what we have used a while ago. Since we have point 10, so this is the area of point 10, then we locate it by using the degree of freedom. So we have here 18 and 0.1, so we have 25.989. So this is 25.989, our critical value. So 25.989. So now that we get the value of the chi-square, and based on our since we have here a value of chi-square which is 30.42, since 30.42 is greater than 25.989, we can conclude that it falls in the rejection region. So, ibig sabihin, yung 30.42 ay somewhere nasa loob ng rejection region. So, let's say na nandito yung 30.42. So, it means that we reject the null hypothesis. So, what can we conclude based on the problem? So, since we reject the null hypothesis, so it means it was proven that the standard deviation is greater than 3 ml. So, now that we have concluded the problem, and since we have determined that we rejected the null hypothesis, I think we are now done by discussing this topic using the chi-squared. So thank you for listening to us, Mr. Bernard Reyes, and I am Paul Jandrie Coronel. Thank you for listening once again.